Hello everyone, in this video we'll discuss about the basic concepts of domain and range of a function. So watch the video till the end. So first we'll discuss what is domain and range. Let f be a function of a into b. The set A is called the domain of the function f, and the domain of a function is denoted by the capital letter D. And the set B is called the codomain of the function f. Now if x belongs to A, then the element in B which is assigned to x is called the image of x and is denoted by f of x. So let A be this set and let x belongs to A and let B be this set and let y and z belongs to this set B. Now let this y belongs to B is assigned to x. This y belongs to B is assigned to x. Then y is called the image of x and is written as y is equal f of x. Now each element in B need not appear as the image of an element in A. As for example, here Z belongs to B, but Z is not assigned to any element in A. So here is the difference between codomain and range. The set consists of all elements of B is called codomain of F. So codomain of F is the set consisting the elements y and z together. But the range of F consists of those elements in B which appear as the image of at least one element in A. So for this case, the range of the function f will be the set consisting only y, as y is assigned to at least one element in A. So range of f denoted by f of A or by the capital letter R. So here is the example. We have an example here. So here the function f is from A to B. Here A is the domain of the function f and B is the codomain of the function f. So set A consists of the element -2, -1, 0, 1 and 2, and this set is the domain of the function f, and set B consists of the element -2, 0, 1, 3 and 4, and this set is the codomain of the function F. Now from these sets we see that 4 is the image of negative 2 and 2, as 4 is assigned to negative 2 and 2. 1 is the image of negative 1 and 1, as this 1 is assigned to negative 1 and 1. Similarly, 0 is the image of this 0. So the range of this function will be the set consisting the elements 0, 1 and 4 only, as 0, 1 and 4 are assigned to at least one element in A. So the range of this function will be the set consisting the elements 0, 1 and 4. But the set consisting all the elements of B will be the codomain of this function. That means the set consisting the elements negative 2, 0, 1, 3 and 4 will be the codomain of this function. Now formal definition of domain and range. So let y equal to f of x, where x is the independent variable and y is the dependent variable. So the domain of the function f will be the set of all possible values of the independent variable x. The domain of a function is determined by looking for those values of the independent variable for which the function is defined. Now, the range of the function f is the set of all possible values of the dependent variable y for the values of the independent variable x. So we will make our concepts clear with two examples. So here we have the example 1. Here the function is given by y is equal x square. Here x is the independent variable and y is the dependent variable. So for this function, domain will be the value of the independent variable x for which the function will be defined, and range will be the value of the dependent variable y. Now from the equation y is equal x square, we see that the function is defined for all real values of x. In other words, we can say that there is no value of x for which the function will be undefined. So when we say that a function is undefined, so here we have a function y is equal 1 over x, and from this case we see that when x is equal to 0, then y is equal to 1 over 0, which is undefined. So from here we see that when x is equal to 0, the function y is equal 1 over x will be undefined. So x is equal to 0 cannot be in the domain of the function y is equal to 1 over x, as at x is equal to 0 the function is undefined. And for domain, we'll consider that set of values of the independent variable for which the function is defined. And since for x is equal to 0 the function y equal 1 over x is undefined, so x is equal to 0 cannot be in the domain of this function y is equal to 1 over x. But in our case we have y is equal x square, and this function is defined for real value of x. For this reason, the domain of our function y is equal x square will be the set of all real numbers. So the domain will be the set of all real numbers, which is written as this. By this symbol we can understand that the domain will be the set of all real numbers, which can also be written as negative infinity to infinity. Now from this function y is equal x square, we see that whatever the value of x is, either negative or positive, the value of y will be always positive, as we are taking a square of the independent variable x. For this reason, whatever the value of x is, either negative or positive, y will be always positive. And only when x is equal to 0, we will have y is equal to 0. And for any other values of x, y will be positive. So the minimum value of y is 0. So look at here, when x is equal negative 2, y is equal 4, x is equal negative 1, y is equal to 1, x is equal to 2, y is equal to 4. So whatever the value of x is, whether negative or positive, y will be always positive. And only when x is equal to 0, then we have y is equal to 0. So the minimum value of y is 0, and any value of y will be positive. So for this reason, the range of the function y is equal x square will be r is equal 0 to infinity, including 0, as 0 is the minimum value of y. For this reason, the range of the function y is equal to x square will be 0 to infinity, including 0. So here is our case. The domain is the set of all real numbers, which can also be written as negative infinity to infinity, and the range will be 0 to infinity, including 0. And we can also determine the domain and range of a function using its graph. So in our case, the function is y is equal x square. Now we will draw the graph of the function y is equal to x square. So this is our x-axis, this is our y-axis, and this is the center. So we know that y equal to x square represents parabola opens upward. So this parabola will be the shape like this. So from this shape, we see that the minimum value of y is 0 when x is equal to 0, and for any values of x, y is always in the positive side of y-axis. So for any values of x, y will be positive, and y is 0 when x is equal to 0. So for this reason, the range will be 0 to infinity, and we see that for any value of x, the function y equal to x square is defined. For this reason, the domain will be negative infinity to infinity. So we have another example here. Here we have example 2. The given function is y is equal to ln x. Similarly, here x is the independent variable and y is the dependent variable. The domain of this function will be the values of the independent variable x for which the function is defined, and the range will be the value of the dependent variable y. Now for this function y is equal to ln x, if x is equal to 0 or negative, then ln x will be undefined. You can use your calculator to verify this, that when x is equal to 0 or negative, then ln x will be undefined. So for any negative value or 0, that means for the interval negative infinity to 0, of course including 0, the function y is equal ln x will be undefined. So for this region, negative infinity to 0 cannot be in the domain of the function y is equal to ln x. But for any positive value of x, y equal ln x will be defined. That means if x belongs to 0 to infinity, the function y equal to ln x will be defined. You can also use your calculator to verify this. So for this region, the domain of y equal to ln x will be the set of all positive real numbers, and this can be written as 0 to infinity. So the domain for our function y equal to ln x will be 0 to infinity excluding 0, as for any positive values of x, the function y equal to ln x will be defined. This can also be written as R positive, which implies the set of all positive real numbers. And this set negative infinity to 0 cannot be in the domain of the function y equal to ln x, as for any negative value or 0, the function is undefined. So here is the case. We see that when ln negative, and the function will be undefined. For ln 0, the function is also undefined. For any positive value, the ln function is defined. For x is equal to 1, ln 1 is 0, and for x is greater than 1 also, the ln function is defined and have definite value. So from here also we see that when x is negative or 0, the ln x y equal to ln x function is undefined, and for any x greater than 0, the function y is equal to ln x is defined and has definite value. Now from this case we see that when x is less or equal 0, the y equal to ln x is undefined. When x lies between 0 to 1, that means x belongs to 0 to 1, the function y equal to ln x has negative value. When x is equal to 1, the function y equal to ln x has value 0, and for x greater than 1, that means x belongs to 1 to infinity, the function y equal to ln x has positive value. So from here we see that when x is greater or equal 0, logarithmic function has negative values, logarithmic function has value 0, and logarithmic function has value positive. So from here we see that y equal to ln x function can take any values when x is greater than 0. So for this region, the range of the function y equal to ln x will be, range R will be negative infinity to positive infinity. That means the set of all real numbers, which can also be written as by this symbol, which implies the set of all real numbers. So here is the case. Domain is the set of all positive real numbers 0 to infinity, and range is the set of all real numbers negative infinity to infinity. So we can also determine the domain and range of this function y is equal to ln x using its graph. So now we'll draw the graph of the function y is equal to ln x. So this is the x-axis, this is y-axis, this is the center 0, so now we know that when x is equal to 0 the logarithmic function, when x is equal to 1 the logarithmic function has value 0, and the shape of y is equal to ln x will be like something like this shape. From this shape we see that for x is 0 negative the function is undefined, and when x is greater than 0 the logarithmic y equal to ln x function is defined, and so for this reason the domain will be 0 to infinity, and for range we see that y can take any values, negative values, 0 and also positive values. So for this reason the range will be the set of all real numbers. This implies negative infinity to infinity. That's it for today. Thank you everyone.